Hi there, I'm Dean Jurek, and welcome to ACM Chemistries Concrete 101. These are a series of short videos, about 15 minutes or so, that are designed to help you learn a little bit more about what goes on inside your plant and about the concrete production process itself. So we hope we entertain you a little bit, we hope you learn a little bit, and we really appreciate you joining us, and we'll see you at the end. Thanks so much.
Hi, welcome back to Concrete 101. Today we're going to talk about admixtures. As you know, our concrete products are made out of sand, stone, cement, and water. Technically, admixtures are anything other than these four basic ingredients. Today we're going to focus on dry cast admixtures, which typically are liquid chemicals that are blended into the concrete during manufacture. They become part of the final products, so we call them integral admixtures. So why do we use admixtures? We can use them to help reduce the cost of production, perhaps by reducing the amount of cement we need to use, or allowing us to make more units per hour, increasing productivity. We can use admixtures to improve the quality of our concrete, such as increasing the compressive strength and density, or reducing the absorption of our units. We can use admixtures to help overcome difficulties in production. For example, helping the concrete to stay workable and not stiffen up early in very hot weather. Finally, we can use admixtures to help us achieve properties we cannot get any other way, such as when we make water repellent block. Today, almost all concrete has some admixture in it. They're valuable tools that help us achieve our performance and productivity goals. So let's get started.
At its core, the dry cast manufactured concrete products business is based on efficiency and volume. We want to make high quality concrete products at the lowest cost and in the least amount of time. We need to make a mixture of cement, water, and aggregates that is able to fill a mold and hold its shape immediately after compaction when the mold is removed. This entire process takes seconds, as opposed to days required for wet cast concrete. Once we made the units, we also need to be able to sell them, and for that, we need to make sure that they have the performance and aesthetics, or good looks, that our customers expect once they're installed and in place in the field. Admixtures help us do all of this. So here's one way to look at the dry cast admixture world. On the left, admixtures that help with production, including plasticizers, densifiers, and accelerators and retarders. On the right, we have admixtures that help with in-place concrete performance, including efflorescence control admixtures and water repellents. Let's start with quality and production aids. Plasticizer or densifier. Most dry cast production plants will use a plasticizer or densifier, and this category covers a lot of ground, but generally these products help do a couple of things. First, they help to disperse the cement grains for proper hydration to get the most strength possible from a given amount of cement, which helps reduce cost. If you take a look at the picture here, you can see the cement likes to form clumps or flocks. This behavior goes on even when the cement is in the mixer. Those cement grains like to stick together, which blocks water from contacting and reacting with the grains trapped on the inside. No cement-water contact means no hydration, and unhydrated cement is wasted cement. It's just filler material at that point. Plasticizers and densifiers break up the clumps, facilitate water-cement reactions, and get that cement hydration reaction going. Besides helping to disperse the cement, plasticizers and densifiers act as a lubricant to allow the dry mixture to feed, flow, and fill the molds better. This produces products with higher densities, increased compressive strengths, and lower absorptions. So, plasticizing, densifying, dispersing, lubricating, what does this mean to me? Well, if you're in production, it makes it easier and faster to feed and fill the mold properly. Less vibration means less wear and tear on the machines. Speeding up the production process also makes it easier to meet your production targets. And of course, better filled molds mean crisper corners and edges and fewer culls. The QC folks appreciate the more consistent heights, better strengths, lower absorptions, and fewer problems. And the accountants like the extra strength and reduced culls, which means we can save money on cement and reduce raw material costs. Last but not least, sales. Customers really appreciate the better looking products, more durable performance, and fewer callbacks. To get an idea of how plasticizers and densifiers help disperse cement and lubricate the mix, let's go inside the lab and visit with Professor Emmett Brown.
Good day. I'm Dr. Emmett Brown. Some of you may remember me from my work with a flux capacitor. For those of you that don't, look me up. Today we're going to talk about admixtures and how admixtures can affect concrete to your benefit. Here we have a sample of raw materials, and I'm about to add the appropriate amount of water to that mix. And as I'm adding it, I'm about to stir it, blend it up to the best of my ability, and water will combine with the cement and start a chemical reaction. And as you can see, this is very dry, does not flow at all, and we're about to address that with some chemical admixture. So I will put in a very small amount of admixture, and no, this is not for recreational use. Put the admixture in, and I'm going to stir this thoroughly. This is what you would be doing as you're putting it in the mixer. So in a mixer, you want to make sure that everything is homogeneous, and homogeneous just means it is in every part, all the parts touch each other. If I sample one thing, it's going to be just like everything else. So as I'm working this, it's becoming less and less stiff, and as it works in, the chemical reaches the particles inside of my blend here, it's going to start to get much more fluid. And this chemical admixture is only one of many different types of chemicals that we put into concrete. Some of them are designed to make concrete set faster, some are designed to set slower, some are designed, like this one is actually to make materials flow much better. So we're about to show you a little bit here about the difference in the concrete we saw before. And as you can see now, this concrete is easy to flow and much easier to use. So that's your demonstration from Dr. Emmett Brown. Until next time.
Accelerators and retarders. Another category of quality and production aids are accelerators and retarders. And these products address flip sides of the same coin, the weather. Concrete is a bit like Goldilocks' porridge. It's no good if it's too hot or too cold. For cement to harden, it needs to hydrate, and the hydration reaction is sensitive to temperature. You can watch our Concrete 101 videos on cement to learn more about the hydration process. Cement hydration needs a bit of heat to kick it off, and then a few hours dormancy while the cement particles and water interact. Ideally, we want our raw material and ambient temperatures in the plant between 60 and 95 degrees Fahrenheit or 15 and 35 degrees Celsius. This is a good temperature to start the hydration process, while also giving us time to work with the product, to get it mixed and through the machine. If it's too cold, say the aggregates in cement are 50 degrees Fahrenheit or 10 degrees Celsius, then the hydration process will not start, and the concrete units will not develop enough strength unless we take some additional action. This could include providing heat in the kiln or using an accelerating admixture, which helps kickstart the hydration process and increases early strength gain. The flip side of the weather coin is when it's too hot. say above 95 degrees Fahrenheit or 35 degrees Celsius, and the concrete stiffens and won't feed, fill, or compact properly. This can be especially troublesome when making 3-color blends, and one of the colors needs to sit in the hopper for an extended period of time. In these cases, a retarder can be useful to ensure that the concrete retains workability until we can form it into our final products. In-place performance aids. Now let's talk about the admixtures that help us with in-place concrete performance, including efflorescence controlling admixtures and water repellents. Efflorescence control. If you're in the paver or SRW business, you've probably heard of efflorescence. It's that white stuff on the surface that nobody wants to see. While efflorescence does not affect the physical properties of the concrete, it does not look good. Bad news alert. Any concrete product that contains cement has the potential to produce efflorescence. Efflorescence is a bit like a bad highway wreck. It's really only one thing that causes the trouble. Usually it's a combination of unfortunate events that come together at the wrong time. At ACM, we call them the 4 factors that all combine to produce efflorescence. Here's a simplified version of how efflorescence occurs. During the cement hydration process, a byproduct called calcium hydroxide is produced. As we see in the graphic, these calcium hydroxide particles in the concrete matrix are slightly soluble in water. So if there's water present in the voids in the concrete matrix, it's fair game for the calcium hydroxide to dissolve into. Over time, the water and soluble salt solution can migrate back to the surface of the unit. At that point, the calcium hydroxide reacts with carbon dioxide in the air and produces calcium carbonate. When the water evaporates, it leaves behind white calcium carbonate deposits or efflorescence. It takes a combination of factors to cause efflorescence, and it follows that to minimize efflorescence, we need to take a good hard look at everything we do. This can include raw materials, mix design, as well as how we manufacture, cure, and package our products. It's a lot to unpack, and in fact, it's another whole video's worth, so look out for that in the future. For now, we'll talk about efflorescence controlling admixtures, or ECAs, which are a vital part of our efflorescence toolkit. ECAs work in several ways, but it makes sense that the primary function of an ECA is to minimize the amount of excess water that can penetrate into our concrete products. Less water means less dissolved calcium hydroxide that can later migrate to the surface and deposit as efflorescence. ECAs can also contain densifiers, so they reduce the number of voids or pathways that the water can take into and out of the unit. Finally, some ECAs also contain ingredients that can react with calcium hydroxide during initial curing to control the formation of primary efflorescence haze. Now let's talk about integral water repellents. Integral water repellents, or IWR, are a key ingredient in the manufacture of architectural CMU, or concrete masonry units. These are used to build single-wide exterior walls, which means that these walls are the only barrier between rain and snow outside and the interior of the building. To help us understand why we need water repellents, we've put together a demo wall here with water repellent and regular CMU. The water repellent side has water repellent CMU and mortar. Rainfall is simulated with a spray bar. As you can see, within a fairly short space of time, the regular unit absorbs water at the face shell surface. This water is then wicked through into the cores and all the way through to the back shell. After 4 hours, if we take a look at the back of the demo wall, we can see the difference. The water repellent wall does not absorb water, even after 4 hours of continuous spray. So what's going on? As we can see in the graphic, most water repellents have a 2-pronged approach. Number 1, block water from penetrating into the unit at the surface, and number 2, an anti-wicking action that limits pathways for moisture that does get through. If we combine water repellent CMU and water repellent mortar, good flashing details, and quality workmanship during the wall construction, they allow us to build high-performance, attractive, single-wide masonry walls. Water repellent CMU are usually specified by an architect. To ensure that the CMU is water repellent and promote confidence in the specifier community, many water repellent admixture suppliers have a certification program. The spray bar test is a good certification test. A CMU is sprayed in the lab for 4 hours, and the inside of the unit is examined to see if any water has penetrated. A good water repellent CMU will be virtually dry inside its cores and on the back and sides of the unit. On the other hand, a regular CMU without water repellent will absorb water throughout. For producers, this spray bar test is a simple, inexpensive, and easy way to do right in the plant. We highly recommend that producers incorporate the spray bar test into their regular QA program. And you can find the test method on the NCMA website.
Let's review what we've learned about admixtures. Dry cast admixtures are liquid chemicals that are added to the concrete during mixing. They generally allow us to reduce the cost of production by allowing us to reduce the amount of cement we may need, or improve productivity by increasing the amount of units we can make per hour. They allow us to improve the quality and appearance of our concrete and to overcome difficulties during manufacture. They also allow us to achieve properties that we cannot achieve any other way. Let's look at some examples of dry cast admixtures. There are plasticizers and densifiers that allow us to improve the quality of our concrete, helping it to flow and fill into the molds easier, improving the performance and appearance of our units, and reducing cost. There are retarders and accelerators. They help us control the speed of hydration of the cement, allowing us to make concrete products in both cold and hot weather. There are efflorescence controlling admixtures, which help minimize the amount of water that can penetrate and move in and out of our pavers and SRWs. This helps minimize the amount of calcium hydroxide that can migrate to the surface and appear as white stains on our products. Finally, there are integral water repellents that we use to make architectural CMU for the exterior of buildings. These help keep the interior of the buildings dry by repelling water at the surface and keeping it from migrating through the units into the building. So that's the basics of admixtures. Thanks for watching. See you again next time.
So that's all for today, folks, but feel free to check back with us anytime on our website, acmchem.com, where you can get more information and more videos on Concrete 101.